Hey besties, good morning. If you're watching this, it's because I am not coming into school today because I don't feel well and I just gotta put me first. So I'm just gonna make this video and hopefully I can make it short, under 10 minutes. I'm gonna go over number 6, 7, and 8. If you're in fourth or fifth period, we already went over 6, so you can fast forward. Or if you didn't do your proof, you can stick around. But I'm just gonna plan it for you and you're gonna write your own proof because I feel like at this point, we know what we're doing. So the first thing I want to do, I want to analyze my diagram and I want to look for one of three things. I want to look to see, do I have any kind of overlapping, right? Are my triangles sharing a side or an angle? Or do I see any vertical angles? Do I see an X? Or do I see any linear pairs? Because those three things can really help me get some sides and angles. So I just want to be clear and I just want to take notice of those three things. So I'm looking at this diagram and I kind of see something cool. I kind of see vertical angles. So I'm just going to go with vertical angles. And on the side, before I even get started, I'm going to write the angle ACB is congruent to angle ECD because vertical angles are congruent. And I'm just going to write that off to the side because that may or may not help me, but I want to make sure that if I need an angle, at least I have that angle up there. So I'm proving that triangle ABC is congruent to EDC. So I am proving this. Sorry. And I know if I am proving triangles congruent, there are only 5 ways. So I know that it's side, 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 angle, side, angle, side, angle, 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 side, or HL, hypotenuse leg. And those are my only options. And I'm looking at this diagram and I'm looking at my given and I don't really see any right triangles or right angles. So I'm going to get rid of HL. And now that I see that the 2 vertical angles are a part of my triangles, I'm probably going to get rid of side, side, side because I think I want to use these 2 angles. So I have an angle already, so I need to get some more stuff. So what they told me is that AB is parallel to DE. So I'm going to mark my diagram and I'm going to recall that parallel lines give me 2 things. So from parallel lines, I can, 1, get congruent, alternate, interior or exterior angles. And what that would look like is some kind of a Z, right? And my Z can be forward or backward. It doesn't matter how my Z is turned. As long as I'm able to draw a Z, then, I have those congruent, alternate, interior angles. Or I can look for congruent corresponding angles. So what that looks like is something like this usually. So we'll see triangles and we'll see 2 angles in the same side of the transversal line on the same spot. So in this case, I hope that you can see that there's a Z. So I can go ahead and I can draw a Z like this. And because I'm able to draw that Z, I know that angle B, I know that angle B is congruent to angle D. And then I could also draw a Z this way. So I can go this way here. And because I'm able to draw that Z, I can say that angle A is congruent to angle E. Well, that gives me 3 angles, and I kind of don't need 3 angles, but I know that I have 3 angles to use. So let's go on to the next given, and I see that AE bisects BD. So BD is getting bisected because AE is my knife. And whatever is getting bisected will come after the word bisect. So BE is getting cut. BE is the segment right here. It's going to get cut into 2 congruent pieces. So if I'm cutting BE into 2 congruent pieces, whoopsie, I know that BC is congruent to CD. Well, I think I have enough. So if I wanted to use B and E. So let's say that I wanted to mention B and D were congruent. I can use angle, side angle, right? Angle, side angle right here. is congruent, whoopsie, whoops, angle side angle here is congruent to angle side angle here. Now, let's say I wanted to use angle A and angle E. Let's say I didn't want to use those two. I wanted to use these two. Then I would use another theorem. I would say angle, angle, side, because we see that my side here is not included. So I can say angle, side, angle is the reason why my two triangles are congruent. Let's say, for instance, I didn't even want to use my vertical angle. So let's say I only wanted to use the alternate interior angles. I can say angle, angle, side, congruent to angle, angle, side. And the reason why I can say these angles, so angle A is congruent to angle E, and angle B is congruent to angle D. The reason why I can make these statements is because I know that's the job of parallel lines. If I have parallel lines, we know that they form congruent alternate interior angles. So I'm going to make one or two or both of these statements, and then my reason will be this. So I want you to go ahead and write this proof out. You have all that you need, and upload it to the stream. Next, we have number 7. So I'm going to go straight to my proof line, and I'm being asked to prove that my triangles are congruent. So I know my options are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. What I also know is that my two triangles are overlapping. So the triangle PRS is this triangle here. And I'm being asked to prove that it's congruent to QSR. So that's this triangle here. So a little strategy I like to use whenever I have overlapping triangles, I like to just separate them so I can see exactly what's going on. So I'm going to go ahead and I'm going to draw a triangle. Oh my God, I'm dying. I'm going to draw a triangle PRS. And then I'm going to over here draw a triangle QSR. And it doesn't matter how Q or straight it is. We just want to have like a visual representation. So PRS, that's this triangle right here. And QSR, QSR is this triangle right here. Well, because they were overlapping, I know that they share a side. So immediately I know SR is congruent to SR because of my reflexive property. Now I want to go straight to my given, and we want to start seeing what we have. So we know that QS is congruent to PR. So I want to mark that. QS is here. PR is here. So we have two sides. So far, I know that I'm going to go ahead and get rid of ASA, and I'm getting rid of AAS because they don't need two sides, and I have two sides, and I'm going to use those two sides. Then I know that PS is perpendicular to RS, so I know perpendicular lines form right angles, so I know that there's a right angle here. And if QR is perpendicular to RS, there's a right angle here. Well, what I see is I have a right angle and I have two sides. Well, this isn't side angle side, because if it was side angle side, I would need this side congruent to this side, which I don't have. What I do have is my hypotenuse is congruent. So I think I'm going to go ahead and use HL for this one. And the reason why is because I have a right triangle and I have two hypotenuses congruent to each other and two corresponding legs congruent to each other. Now, the only thing is, before I can use hypotenuse leg, I need to mention that I have a right triangle. So I mentioned that I have right angles because perpendicular lines form right angles. Then I have to mention that triangle PRS and triangle QSR are right triangles. And the reason for that is because triangles that contain right angles are called right triangles. So you don't have to write that verbatim, but you do have to mention that you have a right triangle before you are allowed to use HL. So I want you to go ahead and finish off this proof. And then my last one that we're going to do is we're proving that XWZ is congruent to triangle XYZ. So this is what I'm being asked to prove. And I'm going to write down my options: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So let's go ahead and write down our givens. And we notice, remember, we want to look for certain things before we get started. We want to look for, and even if I don't say it, that should be something in the back of your mind because I already saw it. I don't know if you saw it, but we want to look for reflexive property. We want to look for vertical angles. We want to look for linear pairs. So I'm not always going to say it, but it's something that you need to keep an eye out for because those things will help you. So there's something going on here I'm not going to mention. But what I will mention is that we have W and Y that are right angles. So I'm going to mark that on my diagram. And we know WX is congruent to XY, so I'm going to mark that on my diagram. And I need you to figure out how we're going to prove that these two triangles are congruent. And I want you to go ahead and write out your proof. And I believe that you have everything that you need to determine what is the best way to prove that these two triangles are congruent. So this is what I want you to do. I want you to upload proof number 6, proof number 7, and proof number 8 to this assignment. And there is a Google form that I want you to complete. It's probably like 5 short questions. Just complete those. And I will see you lovely people on Monday. And I hope you have a good weekend. And yeah, I gotta put me first. And I'm sorry that I wasn't here today, but it's a half day. So I feel like, it's okay. Anyway, enjoy your weekend. Love you guys. And I will see you on Monday.